there, Himanshu this side, and I'm a physics faculty at askIITians. So, welcome to the new chapter, Gravitation. So, in this particular chapter, I don't think we need a very big introduction or very used long introduction. You all know about the gravitation from the grade 5, grade 6, grade 7. This gravitation chapter is basically the basic building blocks if you want to pursue your career as a scientist, right? If you are interested in doing the space exploration and all such things, then this particular chapter should is the basic part of it, right? I hope you must have seen that movie Gravity, and also you are having an idea, right? What are the effects of gravity and what wonders it can do, right? So basically, you will also understand in this particular chapter only what is gravity. Have you been understanding it in a wrong way, or you have been understanding it in a correct way as what is gravity, right? So gravitation is a particular phenomena, right, which was observed by for the first time by the famous scientist. The name is Isaac Newton, right? So first time he observed this phenomena, the gravitation phenomena, and he said that every body is being attracted by the earth, right? So you must be knowing about that famous example that the apple is falling over his head. So that's the gravitation phenomena. So that's the first thing which is said to be in the history, that from where the Newton came to know for the first time, right? So even before Newton, there were many scientists who has worked on it, right? So they have also given their laws. We will be having a small introduction about their laws as well at the end of this chapter, right? So this gravitation phenomena is basically related with the mass bodies. It was observed that whenever you have two mass particles, they always attract each other. It's their property. It's their intrinsic property. Intrinsic property means whenever you have a mass particle, they would attract. There is no other way they can repel each other, right? I'm not talking about the charges and all. That is a different part. So this was observed for the first time, that there is a something different kind of force which must be acting between the earth and the body which you throw upwards. So when you throw a particle upwards, then the body is getting attracted by the earth. So if this object is getting attracted by the earth, we must say that there is some sort of attractional force acting between these two things. Now earth is very rigid, right? So if the earth is attracting the body, it must be exerting some force on it. So by Newton's third law of motion, now I'm talking about the Newton's laws of motion. So do not get confused between the gravitation and the Newton's laws of motion. Newton had also given three separately the laws of motion. Every body, I'm talking about the third force here, third law here. Every body attracts the another body by equal and opposite force. All right. So now here, if the earth is attracting the another body which is there in the space by some sort of force, then that body should also attract the force, the earth. So let's say if I throw this pen upwards, then I know that definitely this pen is going to come down because this pen is being attracted by the earth. All right. So if this pen is getting attracted by the earth, that means earth is attracting a force on it. So exactly same amount of force this pen should also exert on the earth, because for each and every action there is an equal and opposite reaction also. Yes, this pen also exerts a force on the earth, but earth does not move towards the pen because earth is very heavy, right? So it will not produce any huge amount of acceleration in the earth, right? It's a very slight acceleration which this pen would be able to produce in a earth, right? So that's why earth does not move. Yes, earth moves because of the gravitational forces of other planets, the other parts of our solar system, right? And other things also. So they are attracting the earth. There is a gravitational force acting between them. And because of such things, we do see the motion of the earth, which is happening in an elliptical orbit, right? So this kind of discussion we will be doing in this chapter called gravitation. So let us begin now So this is a very introduction session. So in this session, you will be learning about the law of gravitation, which is called universal law of levitation. Of course, you can see the very beautiful picture here. So it's all about the gravitation, right? You can see these planets, all these things are moving in a particular path. So who makes it possible? Someone must be exerting a force on them. So that something is basically gravitation. Gravitational force is acting between these stars and the planets and the galaxies, which is making them to go in a certain path. So that was the introduction to gravitation. So you can see here, now we do not have Newton here right now. We have this kid. So she's sitting under the tree and the apple is falling over it. So how beautiful it is, right? So it's a property of the nature, right? It's a property of the mass bodies. Anything which is having a mass, whatever you can think of which is having a mass, it would always be acting the force on each other for sure. All right. So now going ahead with the phenomena caused by the gravitation. So this part you will understand as we go ahead with the chapter. Like in the end, like in the second lecture, yeah, you will be learning about the gravity and all in very much detail. So in that chapter, what you will be in that particular session, we'll be learning about the gravity part, right? So in more detail, you will understand there. But right now, we can just have a small introduction here. That what is a phenomena caused by the gravitation. So first of all, that because of gravitation, everybody gets attracted. So here you can see this is a beautiful satellite. The satellite is going in a particular orbit, right? The name of this satellite is geostationary satellite. I'll be giving you the small introduction about it at the end of this chapter, the last lecture of this chapter. What is the meaning of geostationary satellites? Okay. So here you can see this is our Earth. Earth is rotating about its own axis, and this stationary orbit, this satellite is revolving around the Earth. So who is making the satellite to revolve around the Earth? There must be some force which is acting upon it. So basically, that force is nothing but the gravitational force, which is acting between the satellite and the Earth. So wherever the satellite goes, the gravitational pull is acting on it. And now, if you recall your circular motion chapter, I hope you have done it before. You have come for this lecture. So in your circular motion chapter, you know that if something is going in a circular path, if an object is going in a circular path, it must have a centripetal force. And centripetal force is always provided with the help of some other sort of force. It can be a spring force, it can be a tension force, it can be a gravitational force, it can be a frictional force also. So circular, so this path is circular for the satellite here, you can see. So who makes it possible to go in a curvical path? So that's the gravitational force. You can see this Fg vector, Fg, the gravitational force, which is making it to revolve in a curvical path. So it is acting towards the center. So and who exerts this force? So the Earth. So that's how we recall the that's how the satellite motion is happening in the space, right? Don't get confused with this part now. That is our next part only. What is that? We'll talk about it. Okay. Now the next part, universal law of gravitation. So coming to the main part of this particular session, we will be taking few questions in this session, which is the main part here, right? Once you understand the law, then we should know how to use it. All right. And we should know how to apply it in different situations. So first of all, the universal law of gravitation. What does it says? It will talk about the mathematical part here, right? So here we have the two objects. This is M1 and this is the second object M2, right? So this M1 and M2 body, they will be attracting each other, right? So this every particle attract each other. Whoever has a mass, they would be attracting each other in the universe with the force which is directly proportional to. So let us write down here. G stands for the gravitation. that the gravitational force proportional to the product of their masses, which I can write mathematically as what? M1 multiplied M2. So that's a gravitational force product of the masses. So gravitational force basically depends on the product of the masses. It's an experimental thing, right? So Newton has come up with this conclusion with an experiment. So we should learn it like that way only. So when you take the product of these two masses, right? So the force of gravitation is directly proportional to that, right? Second thing, it depends on the square of distance between them. So if d is the distance from their center to center, then d is the distance between them. So it will be inversely proportional to that. Okay. So second factor is square of the distance between them. When we combine these two factors, we get the total gravitational force will be depending upon product of masses, as well as it will depend upon the inverse of square of distance between them, d squared over this. Now, what is the proportionality constant? Now, this proportionality constant is very important here, right? So you should understand this part very well, because many questions have been framed in the previous examinations, right? If you see the past year papers of JEE mains, right, and some Olympiads exam also, you will find that the gravitational forces based questions are coming a lot, and we need to understand each and every part here. It shouldn't be like we should simply just remember the formula. We should remember the dependence of gravitational force. So first of all, let us talk about the constant here. So the constant which would be coming into the picture here is capital G, this one. So when we complete the gravitational law, it becomes G m1 m2 over r square. You have to remember it, of course, but always remember the dependence. It depends on the product of masses. Not only m1, product of m1 and m2. Then apart from this, it depends on the inverse of square between them, d squared. And then the next part is what is the gravitational constant? It is capital G. Now the best part, the beautiful part about this gravitational constant is this capital G value is same throughout the universe. 6.67 multiplied 10 power minus 11. It's same. How you can frame the unit that you should know? This unit is Newton, this unit is meter square, this unit is kg square. So take this meter square on the left side, Newton, meter square, and then take kg square in the denominator. So Newton meter square per kg square. That's how we write the unit of the gravitational constant. All right. Now this gravitational constant is same throughout the universe. Suppose you take these two bodies, M1 and M2, right? And now you bring these two bodies, like you place them by a distance of d on the surface of Earth. Same bodies M1, M2. You place them on the surface of Earth by a distance d. You calculate the force. You get it F1. Now let's say you get a chance to visit to a surface of Mars, right? And again you have these two bodies M1, M2, and you separate them by the distance d. So still the force which would be acting here, that would be again how much? Let's say F2. That F2 and F1 would be exactly same. There won't be any difference between them. They would be exactly same force. And why this is happening? You won't find such beauty in the case of charged particles, right? So basically when you change the medium in the charged particle, let's say you have two mass bodies, you place them in the air and you calculate the force. Now same mass body, you place them in the water, you calculate the force. It would be exactly same because capital G never changes throughout the universe. Its value is same everywhere in the universe. Any galaxy you go, anywhere you go, the capital G would be exactly same. Got my point? But if I talk about in contrary to that, there is a Coulombic force, which is for the charged particles. See, the studies of gravitation and the charges, Coulombic force, is quite similar. The formula form is also there is a Coulomb's law in the case of charged particles. So that Coulomb's law is almost similar to the gravitation law, looking wise. Okay, and the major difference is in the Coulomb's law, there will be a constant. That constant would be depending upon the medium, whether you're calculating them in those charged particles, you're placing them in the water, or you're placing them in the oil, or you're placing them in the air. Gravitation law is always same. So first point you should remember is it does not depend on the medium. It does not depend on the medium. It's a very, very important point. We have to remember this. It doesn't depend on the medium. All right. And yes, what factors it depends upon? The product of masses and the inverse square of distance. That's why it is called the universal law of gravitation. So always give a stress on this term, universal. Everywhere in the universe, it is same. So, right. So you won't be getting a different answers for two mass bodies which are separated by the distance d in a different mediums, whether you keep them in the oil medium or you keep them in the uh, water or you keep them in the air. Many times Olympiads has tried to confuse. They give an imaginary situation that there are two mass particles, m1, m2, separated by a distance d. You place them in the air. You calculate the force. And then you place those two same mass particle m1, m2 by the same distance d, but now you are putting them in the water. Calculate the gravitational force. Will it be F? It will be less than F, greater than F. Answer is exactly F. Because gravitational force does not depend upon the medium. I hope you got my point. Now, going ahead. So next part is the question related to it. Now, through the questions, we will try to understand the gravitational law in more detail. So focus on these questions. All right. So let us see the question. First question. A body of mass m of 1 kg attracted by the earth with a force which is equal to. So basically they are saying that you have an object which is placed on the surface of earth. So that's the earth. And radius of the earth, you can remember it, though it should be given in the question, 6,400 kilometers. All right. And this is the mass particle whose mass is 1 kg. Mass of the earth, 6 multiplied 10 to power 24 kg, approximately. All right. Would you want to calculate the force between these two things? So let us write down the gravitational law. By the way, the people who have done the Newton's laws of motion, they have been using it again and again. Mg, right? The gravitational force acting on a body is mg, where if you just simply put g is equal to 10 approximately instead of 9.8, you get the answer 1 multiplied 10, which is 10 Newton. So now I'm giving you as a homework. You try this with this problem also, you would get approximately equal to 10 Newton. More accurately, 9.8 Newtons. So gravitational force is G m1 m2 by r square or distance square. G value is 6.67 multiplied 10 power minus 11. M1 means the body, first body, the earth. So whose mass is 6 10 to power 24. Second body mass 1 kg. Distance between the two bodies is r, the radius of the earth. 6,400 kilometers, so I should convert this into meter. And now you put a square of it. So when you solve this entire thing, I know it would be a bit lengthy calculation, but I'm giving you this as a homework. You should do it for the at least once. I have also done it once in my lifetime, right? So you should also do it once. you will realize that it would come out to be approximately equal to 10 newtons only. More accurately, 9.8 or something, because these radius calculations and all may bit vary, right? So 6400 kilometers and mass can be 5.87 10 to the power 24 kg, like that. So you will be getting it around 10 Newton. So that's the mass force acting on a body which is kept on the surface of the earth. Next question. I will be just taking you now questions only. Simple questions so that you get the more understanding about the law. What is the gravitational force between two objects? Attractive at large distance only? Attractive at small distance only? Attractive at all distances? Attractive at large distances? Repulsive at small distances? Think about it. Is it always attractive or is it always repulsive, or sometimes attractive, sometimes repulsive? First point. Does not depend on medium. Gravitational force does not depend upon medium. Write down the second point. Gravitational force is always attractive. Gravitational force is always attractive. It is never repulsive. Do remember this. It is one of the fundamental force of the nature, which is always attractive with the nature. So attractive at all distances. That's it. You can make it as a important point in your notebook. All right. Now going ahead with the next question. These questions are very important, right? If you can try them once, do it yourself, pause the video here, and then come back if you haven't got the answer, or if you have got the answer, then just match with my answer here. So it is said that gravitational force between two bodies is F. Let's say there are two particles. The gravitational force is F. I can write it as G m1 m2 by r square. It is not given to me. M1, M2, I've just assumed it. Some masses would be there. This is, let's say, M1, this is, let's say, M2, this separation is R. If masses of both the objects are halved without altering the distance, okay, both the objects' mass has become half. So now what would be the new situation? This will be M1 by 2 and this will be M2 by 2. Then the gravitational force between them will become, without altering the distance. So this will be remaining R only. So now I will be writing what? The new force F prime. G m1 over 2 m2 over 2, because the masses are new masses now, m1 2 by 2 m2 by 2 r square. How can we write this thing? See, 2 multiplied 2 will become 4, but that 2 in the denominator, so I can write it as 1 4 G m1 m2 by r square. This thing is F, G m1 m2 by r square. So F prime is equal to what? F by 4. So answer will be F by 4. Now these kind of questions are always important because here we have to always apply whether the object's mass is changing, the product of masses is changing or not. Suppose if somebody would have said in the same question that m1 is made 2 times of its initial value and m2 is made half of its initial value. Calculate what is the new force. It would be same. Because product of masses, you see, what was the product of masses initially? M1, M2. What is the product of mass finally? 2m1 half m2. Now this 2 got cancel out. So m1, m2 again. So if product of masses are not changing, then simply we can say that gravitational force will be exactly same. But here the product of mass is becoming 1/4, so that's why the gravitational force will also become 1/4. Let's take one more question. The distance between two bodies becomes 6 times more than the usual distance, right? So what will be the new force now? Again the same thing. Two bodies m1 m2 separated by a distance r. What is the gravitational force? G m1 m2 divided by r square. Now let's say we make the distance 1/6. Oh sorry, 6 times. Now the distance becomes 6r. So what will be the new gravitational force? G m1 m2, but now in place of r I'll just write 36r squared. Just a time pass question, right? So now you can say this term, if you see simply, G m1 m2 by r square. This is nothing but r only. This will become F over 36. Sorry, this is F prime, new force. So new force will become 1 by 36 times the original force. All right. So let's take one more question. The last question. I hope you are able to understand all the questions. Simply just use the gravitational law. And do remember, it depends only on it does not depend on the medium, right? It does not changes when you change the medium. And one more thing, it is always attractive in the nature. And it is proportional to m1 m2 and inversely proportional to the distance square. This is based on the Newton's third law of motion. So Newton's third law of motion says for each and every action there is an equal and opposite motion. Earth attracts moon with a force of 1020 Newton. That's a very huge force. The moon attracts the earth with a gravitational force of, means earth is pulling it. Earth is pulling it with a force of 1020 Newton. With how much force the moon will be pulling the earth? Then the moon attracts the earth with a gravitational force of, means by how much force the earth will be getting attracted by the moon. Try to calculate. Pause the video here, think about it. Will it be greater than 1020 Newton, equal to 1020 Newton, or somewhere in between 10 to 20 Newtons, or less than 1020 Newton? Very simple. For each and every action, there is an equal and opposite reaction. So if earth is attracting moon with a force 1020 Newton, then for this action, there will be an opposite reaction by the earth, by the moon. It would also be attracting the earth with the same force. So answer is exactly equal to 1020 Newtons. It's that simple. Just remember that what we have done today, gravitational law, G m1 m2 over r square. Depends upon product of masses. If product of mass is constant, gravitational force is constant. Distance between them is constant, gravitational force is constant. You change the medium, no effect of medium changing. Third, always attractive. Why I'm writing them again and again? Because these things you will find when you will be solving the study material and your NCERT questions and in your Olympiads previous year also. So just make a note of it, and it's a very important points, the point number 2 and 3. All right. So that's all for the first law of gravitation. I hope you have understood it. If you have any confusion, just put it over the PDF, right? You can ask your queries there. That's all from my side. Thank you so much, guys. Enjoy. Bye bye.